Okay, so then the next one is malware analysis. So look, this is one area where it is not a sandbox, right? So submitting an executable that's, polymorphic and encoded and things like that, it may be able to pick up some things, some indicators, but the confidence level may not be as high. What you tend to want to do is pull out, if you want to use LLMs to do some initial malware analysis, you can do things like get the file hash, get the file name, or even get the strings out of the executable, and then pass that to the malware, to the LLM. So if we have a look at the malware analysis, so we've got a malware analysis strings. So this is, if we have a look at this file, it's a set of strings that have been pulled out of an executable, right? And we're going to submit those strings to the LLM to say, are these malicious strings or is it safe, right? So again, we're going to upload the malware analysis strings. Again, you could upload the file name and the file hash as well if you wanted to. And so we're saying, we'll let this run, but analyze the submitted file by analyzing examining the file's strings for potential indicators of compromise or functionality suggestive of malware. Provide me with context around whether it looks like a false positive or is in fact malware or a hacking tool. Provide the strings that commonly relate to malicious functionality that were detected. Be thorough in the technical details, but keep the response brief, not including descriptions. As a conclusion, again, provide 3 bullet points, whether it's malicious, based on the threshold of the number of strings, what the file may be doing, and what steps should be taken with systems where the file was found. So you can see here, again, the indicators of compromise have been extracted and analyzed, and context has been given. So command and control indicator. So like a reverse TCP payload, for example, connecting to an external IP address on port 4444, which is the default port for Metasploit, indicates attempts to connect to a remote server on a particular port, specifically a reverse shell. There's a suspicious URL based on the random domain name, as well as things like, it's quite common for things like image files to be used to download additional payloads. Temporary file directory usage, so Windows temp is often used, as we saw before, for dropping executables in by malware. User agent spoofing, potentially faking what version of browser request it's making as it's downloading, for example, the second stage backdoor. System information gathering, so there's some internal API kernel hooks, kernel functions that it's calling to be able to interact with the operating system. As well as file download and execution functions that are quite common, as well as network communications that are quite common, as well as the shell execute, obviously executing a shell. There's also anti-debugging techniques. So these operating system functions, so is debugger present? They're quite often used for detecting whether someone's doing malware analysis on the executable, and therefore it detects a debugger is attached and just exits, so you can't actually have a look at what the functionality is. So all of those were able to be analyzed, and it certainly doesn't look good. And conclusion, likely malicious. The presence of the strings related to remote control, network, suspicious network activity, system manipulation, and anti-debugging indicates malicious file. Potential actions: the file appears designed for remote control, data exfiltration, and evasion of analysis through those debugging hooks. And then recommended next steps: isolate systems where the file was found, conduct a full malware scan using updated antivirus and review network logs for signs of data exfiltration or compromise, considering engaging a security professional for in-depth analysis and remediation. So that allows you to, that gives you a pretty good, rather than uploading the executable, which you can do and get the system to, the LLM to actually extract the strings out. I've just found that that's not as efficient or stable as actually extracting the strings yourself. So again, we've got... Okay, so for the malware analysis, we can run this from the command line. So this time we're sending our malware analysis strings file, which we've created. And then we've sent our prompt file, which is the malware analysis strings prompt, to be able to tell ChatGPT how to analyze our malware or potential malware strings within the file and what output format we want. So depending upon the size of the file that's getting analyzed or how many files, can determine how long this may take. You can see here, there's several indicators of compromise. There's the executable command, there's suspicious domains, there's temporary files, as well as suspicious Windows calls. And then based on the conclusion, it's likely malicious, and some recommended steps for actually isolating it.